Hello everyone. Today I'd like to show how to measure the magnetic field of the Earth. So if we place a compass on the surface of the Earth, the North Pole is directed to the direction of the north. And pole in the direction of the north. By using the compass, we could find out the direction of the north. So this is the magnetic field. The Earth also we have learned the current can produce the magnetic field. So if we consider the current is flowing in these directions, you can use a right hand to find the direction of the magnetic field formed by this current. Formed magnetic field depends on the distance from the current. If we consider the position near the current, magnitude of the magnetic field is bigger compared with the magnetic field distant region from the current. I create a device, current flowing on this code. Then we'd like to find the direction of the formed magnetic field. Your thumb directed to the current. Then you can move your fingers. You should use your right hand. The direction of the fingers correspond to the direction of the magnetic field. So this means magnetic field is produced at these directions. Magnitude of the magnetic field is stronger in the close region to the current and it becomes weaker in the distant regions from the current. Now, as the magnetic field is directed in this direction, so north is here. And if we use current form the magnetic field in this direction, then the formed magnetic field is in this direction using the right hand rules. The total magnetic field is given by the sum of the two magnetic fields formed by the Earth and formed by the current. So you can use the sum of the two vector quantities of the magnetic field to find the total magnetic field. So if magnetic field produced by the current is weak, so in this corresponds to the small I, we could expect the total magnetic field is not very different from the Earth's magnetic field. So this is the situation. So the compass is placed far away from the current. Then I use a battery to generate the current. So current is flowing in this direction. Then formed magnetic field is this direction. Actually, the compass is deflected in these directions because of the formed magnetic field due to the current. You can find the change of the direction of the compass. See? So total magnetic field is directed these directions. This is a correspond to the total magnetic field. We could consider a really large case. Now compass is placed to the very close to the current. Magnetic field formed by the current becomes stronger. Then total magnetic field is dominated by the magnetic field due to the current. Then if we change the height of the object, the magnetic field becomes exactly equal to the magnetic field of the Earth. The direction of the total magnetic field is directed northwest. So this corresponds to the 45 degrees. I'd like to find out the height of the object when the compass is directed to the exactly the northwest. So 45 degrees from the north. So let's see. So current is flowing. Then magnetic field due to the current becomes exactly equal to the magnetic field of the Earth. Now you can find that Earth's magnetic field exactly same with the magnetic field due to the current. So by finding a magnetic field due to the current, we could find the magnetic field of the Earth. Okay, so if I connect the positive pole to this side, then current is flowing in this direction. Then as I showed, the magnetic field formed of the current and the magnetic field of the Earth, the compass is directed to the northwest. But if I change the pole from the positive pole this one and the negative pole is the opposite side, then current is flowing in this direction. Then which direction compass is directed toward? As you can easily imagine, compass is directed the northeast. Okay, now we'd like to find out the Earth's magnetic field. So magnetic field due to the current is given by the mu sub 0 I over 2 pi x. Mu sub naught is given by the 4 pi times 10 to minus 7 times the Tesla times meter per amperes. Therefore, what we need to measure is the current of I and the distance from the current to the compass of x. Let's first measure the x using the rulers. Between the compass to the rulers, you can read the numbers It's 7 centimeters. X is 7 centimeters. So now we have a 7 centimeters. Then we'd like to determine the V, voltage of batteries, and the resistance of wires. So at first we'd like to measure the V using the digital multimeter. You can read the numbers and it becomes 1.376 volt. So voltage of a battery is given by the 1.4 volt. Then we'd like to measure the resistance of a cord. So you can find that the resistance becomes a 0.1 ohm. So R becomes 0.1 ohm. So voltage of a battery is a 1.4 volt. And the resistance of R is measured to be the 0.1 ohm. So by calculating these numbers, the current becomes a 14 amperes. Then you can substitute this X here, and the current of the 14 amperes is here. So we could calculate the B sub I is equal to mu, you can substitute mu sub 0. It's a 4 pi times 10 to minus 7 Tesla meter over amperes. So as the I's, you can substitute 14 amperes divided by 2 pi times 7 centimeter is a 7 times 10 to minus 2 meters. Then 4 pi and 2 pi is cancelled to become 2's. And the meter is cancelled. And the ampere is cancelled. And 7 becomes 2. So it becomes, so unit becomes only Teslas we have. So it becomes 4 times 10 to minus 5 Tesla. So this is the magnetic field of the Earth. So if we use a Gauss instead of the Teslas, Gauss is equal to 10 to minus 4 Teslas. So if we use a Gauss instead of Tesla, this becomes 0.4 Gauss. So this is the magnetic field of the Earth. Okay, so we can easily measure the magnetic field of the Earth by measuring the current and the distance to the compass.